Welcome back to our lesson, and let's continue with the lesson. So we are going to be now solving equations using the multiplicative inverse. Now remember what the multiplicative inverse is. It's the one where we're multiplying with another number and the result has to be a 1. So when we solve for equations using the multiplicative inverse, we need to, again, identify the action that was taken and reverse those actions to get back to the same place. And what we must always remember is that an equation is like a scale. What is done on the left-hand side must be done on the right-hand side as well. So the inverse operation for multiplication is division, and the inverse operation for division is multiplication. So let's look at the following example. We have here 3x is equals to 48. And that simply means that a certain number is multiplied by 3 and the result is 48. So it means that this number was multiplied by 3. So how do we now reverse that action? We need to apply the multiplicative inverse, and that is division. So that means that we are going to divide by this 3. That's how we are going to reverse it. Or it is the same as us multiplying by the multiplicative inverse. And the multiplicative inverse of a 3 is 1/3. So we are going to multiply by 1/3. And remember what I do on one side of the equation, I need to go and do on the other side of the equal sign. Now, if we say there 3 multiplied by 1/3, that is going to give us a x. 1x, because 3 multiplied by 1/3 is 1, and that is going to leave us with just the x. And on the other side, if we say there 48 multiplied by 1/3, that is the same as saying 48 divided by 3, and our answer there is going to be 16. Let's look at more of these equations. So the first one there, we have a number multiplied by 8 is equals to 56. So how do we solve for an equation like that? Remember, you can either multiply by the multiplicative inverse, which is 1/8, or we can divide by 8. We are reversing a process that was done. So if I now multiply by 1/8 and multiply by 1/8 on both sides, because what we do on one side must be done on the other side as well. So if I say 8 multiplied by 1/8, that is going to give me 1x. And if I say 56 multiplied by 8, that is going to give me, 56 multiplied by 1/8, that is going to give me a 7. Let's look at the next one. So the next one there says 1/2 x is equals to 15. So it's 1 divided by 2x is equals to 15. Now, what is the multiplicative inverse of 1/2? If you are thinking of 2, then you are absolutely correct, which means that I need to multiply both sides by 2. Now, 1/2 multiplied by 2 is 1, which is going to give us with just the 1x, and 15 multiplied by 2 is 30. So our answer there is 30. Let's now go on to the next point of our concept map, and that is solving exponential equations. So let's look at how that works. So we are going to solve for x there, and we have 5 exponent x is equals to 125. Now the first thing we need to do is to write them in exponential form. So if we are looking at 125 written in exponential form is just 5 exponent 3. Now when you look at these two powers, they are equal to each other. So if they are equal to each other and both of them have a base 5 or the same base, then it means there that the exponents are also equal. So this means that x is equals to 3, because 5 exponent x, exponent number that we don't know, is equals to 5 exponent 3. So that number that we don't know is 3, because the powers are equal and the bases are the same. Let's work on these two examples. So the first one there says 3 multiplied by 7 exponent p is equals to 147. So the first thing we need to do is to apply the multiplicative inverse of that 3 so that we are left with just the 7 and exponent p. So that is going to be 3 multiplied by 7 exponent p, and we are going to multiply that p with, we are going to multiply the 3 with its multiplicative inverse, which is 1/3. And what I do on one side of the equation, I need to go and do on the other side of the equation as well. So 3 multiplied by 1/3 we know is 1, so that just leaves us with 7 exponent p. And 147 divided by 1/3, divided by, 147 multiplied by 1/3, or it's the same as dividing by 3, that is going to give us a 49. Now we know that 49 can be written as 7 exponent 2, and on the left-hand side we have 7 exponent p. That means that our p is equals to 2. Let's move on to the next one. Now we have 2 exponent k is equals to 64. Now firstly, we are going to write 64 in exponential form. Now remember, we had many ways of writing 64 in exponential form, but now we wanted to have the same base as the left-hand side. So we are going to write it as 2 exponent 6. Now, because the powers are equal to each other and the base is the same, that means that the exponents are also equal. So therefore, our k is equals to a 6. Let's look at the last one there. We have a power where 4 has been added to that power, and the answer is 173. So the first thing we are going to do is to apply the additive inverse of 4, and that is going to give us the answer. So the additive inverse of 4 is -4. So in actual fact, we are actually adding a -4. And what I do on one side, I must go and do on the other side. So we are going to add a -4 on the other side as well. So what is going to be the result there? Now 4, when we add -4 to 4, that's going to give us 0. And then we have 13 exponent m. And on the other side, if we say 173 and we add a -4, that is going to give us 169. Now, if we express 169 in exponential form, that is going to be 13 squared. And because the powers are the same, they are equal, and because the powers are equal to each other and they have the same base, that means that the exponents are equal, so therefore m is equal to 2. And that's how we solve for exponential equations. Let's move on to the last point of our concept map, and that is solving for word problems. So solving for word problems is simply taking the word problem, turning it into an equation, and then solving for that word problem. So the first one there says, the sum of 2 consecutive numbers is 25. Now consecutive means that the numbers come after each other on the number line, and these are whole numbers that come after each other on the number line. So the sum of 2 consecutive whole numbers is 25. So this means that, of course, we don't know what the first number is, so we are going to use x to represent that number. And sum means that we are adding. Now, but then what is the number that comes after x? So because we don't know what x is, but we do know that the number that comes after will be whatever the value of x is plus 1. So in other words, if x is 5, then we know the next number will be 6. If x is 50, we know the next number will be 51. How do we know that? The numbers are consecutive. So whatever x is, the next number will be that same x, and we add 1 to it. So the sum of 2 numbers, there's x plus 1 is equals to 25. Now we can solve for that equation. Now we have here x, and we are adding another x. So if I already have x and I'm adding another x, that means I have 2 of these x's. And then I've got a 1 there. We are adding 1 to those 2 x's, and we have 25. Now this has been turned into a nice equation where we say a certain number multiplied by 2, and then we add 1, that is going to give us 25. So let's solve for that quickly. So that is going to be us now using our multiplicative inverse and our additive inverse to solve for this. So the multiplicative inverse of 1 is going to be adding a negative 1. And what I do on one side, I must now go do on the other side as well. Now 2x plus 1 plus a negative 1 will leave us with just 2x. And on this side, we have 25 plus a negative 1. That will give us a 24. Now a certain number multiplied by 2 is equals to 24. What is that number? For us to find that number, we are going to use the multiplicative inverse. That is us now multiplying the 2 with the 1/2. And if I do the same thing on the right-hand side, the 24 multiplied by 1/2. Now 2 multiplied by 1/2 is going to give us x, and 24 multiplied by 1/2 is the same as 24 divided by 2. That is going to give us a nice 12. Let's do the last one for this lesson. And it says there, Karabo is 5 years older than his brother. The sum of their ages is 19. What is his brother's age? So we look at it carefully, we read it carefully, and we make an equation out of it, or we set up an equation from that. So Karabo is 5 years older than his brother. So let's say that his brother's age is P. Now, we don't know how old Karabo's brother is, but we do know that Karabo is 5 years older than the brother. So if the brother's age is P, then Karabo's age will be that his brother's age plus 5. So whatever his brother's age is, Karabo is 5 years older. So we are going to add 5 to the brother's age. Now, they said here the sum of their ages. So this means that now the brother's age plus Karabo's age is going to be equals to 19, because the sum of their ages is 19. So now let's put it properly as an equation. This is going to be now 1p plus another p will give me 2 p's. And then we are adding 5 to those p's, and the result is 19. So let's apply our multiplicative and additive inverses there. Now we are going to start with the 5. The additive inverse of 5 is adding a negative 5, because that is going to give me 0. And what I do on one side, I must go and do on the other side as well. Now 5 plus a negative 5 will leave me with just 2p. Then on the right-hand side, we are going to have 19 plus a negative 5. Adding a negative number is the same as subtracting that natural number. So that is going to be 19 minus 5, which is 14. And now we are going to apply the multiplicative inverse. So that is now 2p. That is now 2p. We are going to multiply that by 1/2. And what I do on one side, I'm going to do on the other side as well. So 2p multiplied by 1/2 will just give me the p, and 14 multiplied by 1/2 will give me 7. So this means that the value of p is 7, and the value of p, remember we said, is Karabo's brother's age. So it means that the brother is 7 years old, and that would make Karabo, yes, 12 years old. You are correct. I hope you enjoyed this lesson, and I hope you join us next time as well. We will see you next time. Goodbye.